In this video, we want to consider two more laws, which we call the change of base laws and the reciprocal. It is important you know that. So if I have log b base a, it is always the same as log b base c over log a base c. So what you have done is you have tried to change the base. That is exactly what you tried to do, trying to change the base appropriately, and that is one of the things you have just done here. Now the other one is the reciprocal. Now the reciprocal law is that if you have log b base a, it's equals to 1 over log a base b. Say the difference very well. When you have, so let me do some quick cap here. So in this case, for example, if I have log 8 base 2, it implies that I can have log 8 divided by log 2, where the log is now base 10. Now don't forget that log 8 is the same thing as log 2 raised to the power 3 over log 2, which is the same thing as 3 log 2 over log 2. Log 2 cancels log 2 and the answer is 3. And naturally, log 8 base 2 is 3. So you can see, now it is easier here, but when you have those numbers that you can't easily manipulate like this, this is where that law comes in very handy. And for this reciprocal, what this reciprocal is telling us is, if I have log 8 base 2, it is the same as log 1 over log 2 base 8. And that is just the truth. So one of the things I would like you to do is to prove by checking if this is right or wrong. Now there is one more law that I feel it's important we know, even though you may not really come across it in the exam. So for example, when you have log x base a squared, when the base is a power, it is 1 over 2 log x base a. When the base is power, what you do is the reciprocal of the power becomes the multiplier. Now let's check how true what we have just done here, how true it is. So what is the value of log 8 base 4 with your calculator? If you use your calculator, you will get 3 over 2 using calculator. So now log 8 base 4 is the same thing as log 8 base 2 squared. So using the rule now, since the power is 2, the reciprocal becomes 1 over 2 log 8 base 2. Base 2, sorry. And what is log 8 base 2? We know log 8 base 2 to be 3. And that gives us half times 3, which is 3 over 2. You can see that? That is how good logarithms can actually be. Yeah, very, 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 very good. So let's try a question. Log 11 base 8 is going to be what? Log 11 divided by log 8. So I know this to be in base 10. So all I just do is I use my fraction key symbol on my calculator and I do log 11 divided by log 8, and that would give me approximately 1.15 to 3 SF. That is how it works. Now, another method that you can use to solve this question, or you say, let log 11 base 8 equals x. So this gives you 8 raised to the power x equals to 11. And you say, oh, let me add log to both sides. This is a power, it becomes a multiplier. So you have x log 8 equals to log 11. So to get x, I divide both sides by log 8, divide these two by log 8. And definitely my x will be approximately 1.15 to 3SF. So this is how you use the law effectively. Now, before we go, I like us to consider two things very quickly. Some extended question though, and this will be the last example for this particular law. So it says solve the equation log x base 5 plus 6 log 5 base x is equal to 5. Now, you will observe something here critically. This is base x, this is base 5. Another thing you will observe critically is this is log x, this is log 5. They're being switched around. So can we say recall that log five base x is same thing as 1 over log x base 5. Using that's by what law now? By reciprocal law. So that gives us what? Log x base 5 plus 6 times, so which will now be 6 over log x base 5 equals to 5. Oh, this is 6. This is already becoming 1 over log x base 5. So 6 times 1 over log x base 5 will become 6 over log x base 5. So if I let p to be log x base 5, that means I will have p plus 6 over p equals 5. So that will give us what? We could say 6 over p equals 5 minus p. Cross multiply, that gives us 5p minus p squared equals to 6. So which is the same thing as what? P squared minus 5p plus 6 is equals to 0. So try to factorize this. You will have p squared minus 2p minus 3p plus 6 equals 0. So for the first bracket, p into p minus 2, the minus 3 into p minus 2 also equals to 0. So p minus 2 equals to 0, which shows that p is 2. Take notes. P minus 3 equals 0, which shows that p is 3. But note, we are not looking for p, we're looking for x. But we represented our p to be something. So we can say log x base 5 is equals to 2, which means that x is 25. Log x base 5 equals to 3. That's, don't forget, from this. So, which is going to definitely be x to be 5 raised to the power 3, and that is 125. So therefore, x is 5 and 125. So this is something you need to put in mind in applying the reciprocal law in solving equations. I hope this video helps. In our next video, we will be concluding logarithms by solving logarithmic equations. Thank you.